Thank you for joining us. My name is Dishan Kumar, and today we have a very interesting topic. We're actually talking about DNA, our genes, and actually the essence of life. So today with me is my guest is Professor Dr. Zafarina Zainuddin, the Director for Analytical Biochemistry Research Center for USM. Thank you, Prof, for joining us today.
Thank you for having me here.
So, Prof, the first thing that that came to me when I was looking over my notes and things like that, the first question was, what is actually DNA Ancestry?
Okay, so DNA Ancestry is actually based on one study using DNA mitochondria. This DNA is very unique to human being because it is only inherited from the mother line. Saying that means your DNA can be traced to your great-great-great-grandmother, so you will have the same mitochondrial DNA profile as your great-great-grandmother. So one of the biggest thing in this mitochondrial study started around 1970s, where they came out with this theory saying that as an out of Africa, saying that our modern human actually traveled out from Africa around 70,000 years ago, and then this group of people actually traveled south to the land called Sundaland. Previously it was
Southeast Asia.
Yeah, Southeast Asia, and then another group traveled north to the Europe and everywhere to the north side of the world. And the special thing about this study, they found that the oldest or the most recent common ancestor of this this modern human, was actually found in Africa, and that particular DNA type was called mitochondria Eve, and this actually DNA was actually dated about 200,000 years ago.
Oh wow, 200,000 years ago.
Yeah.
Okay, and speaking about all that, it sounds so interesting, getting to know where you're coming from, where we actually started, where life started and things like that. How did you actually start in this? What is your story?
Okay, when I did my PhD at University of Glasgow, first actually I started with a very quite complicated proposal. I wanted to study on this disease called syndrome infant death.
Okay.
So also known as the baby cot death, something like that.
Okay.
But my problem was to get sample was very difficult. So, and during that time, my supervisor was actually analyzing this Neanderthal's DNA in our lab. So he did ask me, do you have any aborigines group in Malaysia that are very interesting to study, that we can relate to this out of Africa theory? And that was the time I was like, yeah, we do have these Negrito people, so they might be actually one of the descendants of the oldest population in the world. So I came back to Malaysia and then did some background check and everything. So I found these Semang groups. They were actually being cited somewhere, saying that they are actually among the relic population, and I think they are worth to study that group. So what I did was actually to compare this orang asli DNA to the Malays, and that is where I actually started to get this interesting finding, where we can find some of the orang asli DNA that are very old, up to about 60,000 years ago, that was also found in the Malay DNA.
Okay.
So when I wrap up my study, I finished, submitted my thesis. The first thing that I did when I came back to Malaysia was to apply a grant, and then I studied I continued the study using mitochondrial DNA for the Malay population, but we actually narrowing down into the subgroups, Malay sub-ethnic groups, and we did some comparison with the Chinese, with the Indians, and there we can find that the haplogroups for Malays are very specific to Malays, and the haplogroup for Chinese can be traced back to the China mainland, and the Indians, of course, to the Indian continents.
And speaking about that, maybe we can talk about a bit more. You were saying the Malays have a different type of mitochondrial DNA, the Chinese and the Indians and things like that. Is this a very big difference, or is this just to show that we actually came from different parts of the world at a specific time and things like that?
Yeah. Okay, so let's say if I'm talking about the Chinese, yeah. So the Chinese and the Malay and the Indian, we are actually comprised in one big haplogroup known as the M haplogroup. And we have these Europeans, they are more into these R and N haplogroups. So these major haplogroups, macro haplogroups, are continent specifics.
Oh, okay.
All right. But in the M, we have ME, MD, MC. These MD, MC, M21 and everything, they are ethnic specific. So by looking at narrowing down the search, by looking at more sequences from the mitochondrial DNA, we can actually cluster them in a smaller groups. But again, I can actually have a big group of Southeast Asian, I can have big groups of East Asian. So these are the differences between, that we can say that small differences between the races.
And speaking about that, the question of race. Now, if we talk about DNA ancestry and finding out where people come from, things like that, aren't we kind of, won't questions be actually asked about compartmentalizing people into boxes or into races, and does that actually divide us more than unite us?
Putting us together.
Yeah.
All right. Okay. First of all, when I started my study, my specialty was actually in DNA profiling. And the use is actually in crime investigation.
Oh, okay.
So when we use DNA in crime investigation, when we get a DNA sample or profile from a crime scene, and when we try to actually compare to the suspect, it's not actually to find him guilty, but it's more into to exclude him from the case. So when a suspect is not guilty, so it will be much easier for them to actually to carry on with their lives, right? So that is the main role of DNA in crime. So same goes like this one. We are actually looking, the good thing is actually for us to understand where do we come from. So are we actually related to each other? So let's say myself, when I did my PhD, I did on my DNA.
Oh, okay.
So interestingly, during that time, early 2000, I couldn't find where I came from. So after a few years later, when my PhD student started to actually test more people and the database is growing, so then only I can actually, my DNA type, mitochondrial DNA type was actually very specific to Papua New Guinea.
Oh, wow.
So then only I know how my great-great-grandparent, my great-great-grandmother traveled as far as from Papua New Guinea to the Java, because my great-mother was actually from Java, and then up to Johor, and there is where my great-grandmother family started. So the good things are there, and if you want to actually look at the negative point, people
anything,
can just
negatively. Okay.
Yeah.
Talking about that, if a person does a DNA ancestry, what information do they actually get?
Okay. For DNA ancestry, a very specific study, we will only look at your mitochondrial DNA.
Okay.
So looking at your all these single nucleotide polymorphisms, and also there are also called length polymorphism that will actually group your mitochondrial DNA into that specific haplogroup. First, we will try to put you into these macro haplogroups, and from there, we will actually search down using specific primers to later put you into these ethnically specific haplogroups.
So it's like a filtering system. You actually put it into big groups and then you filter it down to small groups.
Correct.
Oh, okay. All right.
Then later on, what we can do actually from what I did in my lab, so I will actually put your information into a database. So that particular database will actually create a phylogenetic tree, like a tree, where to put you, where are you closest to? Maybe you will be actually, like yourself, maybe you will put into the southern part of India or northern part of India. Okay. Where did you actually come from?
We'll have to take a short break. When we come back, we'll actually talk about the pitfalls of genetic testing, maybe the difference between DNA testing and gene testing and things like that. Stay tuned, we'll be right back.